Hello students, welcome to this program of teaching and learning online. So we are going to continue our lesson. Me, I am Sylvester Nagandwa, your science teacher from TTC Zaza. So we are going to continue our lessons as usual. Now we are going to continue with polymerization. You remember that last time we have seen the lesson concerned with the terms used in polymerization. Now we are going to continue by seeing different types of polymerization. Here we are going to enter in our lesson in deep. Okay, let's start now.
That's the dream. Baby, hold me tight. You said you'd never leave me, yeah. Babe, I keep on falling. Vas-y, comme ça, c'est bon. J'adore.
So now I'm going to start this lesson. Hope you enjoy this lesson of Unity 4 about polymers and polymerization. I have displayed my contact so that any support, any addition, you can contact me so that will make this program more effective. Hope you are staying home to be safe in this period of fighting against pandemic COVID-19. As you can see here, we are in the same context. We are in the same context of TTC's Teacher Training College. This lesson is designed to be taught in Year 3 SME. Also is chemistry course, as I have told you before, because this is part 2 of it. And the unit is polymers and the polymerization. The lesson of today, as I have told you, is types of polymerization. So, polymerization, I think you remember the definition of polymerization. Because I discussed the last time about polymer, I discussed about monomers, I discussed about polymerization. Now I'm going to proceed. You know that polymerization, in order to have polymer, we pass through a process called polymerization. Polymerization is a process by which the monomers, units of monomers, are combined together by covalent bond in order to form a very big molecule, which we call macromolecule, which are polymers. And then those polymers have a structure of a chain, of a large chain of polymers. This process of forming these higher molecular weighting molecules is called polymerization. Now we start with an activity, because last time I have left your homework and I will collect it with the next one I am going to give you now. And we are going to start with an activity, so that we enter into the lesson with a package of background. So let us start with this activity. So in this activity, you're going to observe carefully the following chemical formula, the following chemical reactions, and then you answer that question. You compare and contrast the two chemical reactions. You will see the similarities and the differences, and then you contrast, you compare and contrast. Okay? So have your time of 5 seconds, because the time is rushing. When the video become very large, you told me that you become bored. So I am going to try to make it very small. So observe it carefully and then see, give me some observation about comparison and contrasting. So I can help you here. As you can see on reaction A. This is reaction A. Here is reaction A. In the reactant, you can see that you have vinyl chloride. You have vinyl chloride. You remember that is a monomer. This vinyl chloride, you see it. I hope you can see it. I hope you can see it. This is vinyl chloride. This is vinyl chloride. This vinyl chloride is going to form what? To form polymers. It's going to form what? To form polymers. How it forms polymers? When you're going to form polymers with this vinyl chloride, you see that you will need to open this double bond. When you open this double bond, as you have seen in the previous lesson, you get a repeating unit, which is a monomer, and this repeating unit can form a polyvinyl chloride, as you can see here on this part. This is a vinyl. This is what we call a polyvinyl chloride. As you can see, this is polyvinyl chloride, where some of here you can see there is here one unit, and here is a second unit. From here you can see. Here is there is a second unit here. This is the first unit, and here is a second unit. You see that depending on the degree of polymerization, you can form a long chain. Here I have taken n equal to show that this can make a chain. So, and as I have told you, also observe on this second reaction, if it does in the same way as the first reaction. You can see here we have first reactant product, first reactant compound, and also the second reactant compound. So here you can see that there is a reaction between them, and also there is something here that is remaining. So are those reactions done in the same way? So start to think about those reactions and contrast their differences and similarities. Hope you have done it. Now we can share our observation, because there are some observations that must be common. You can get some that are different from mine, but we can share what I have observed in these two reactions. So my observation is that A and B are polymerization reactions because all of them combine together two monomers. Some are common, others are different. But this cannot stop them to be polymers. The product that they have found is polymers. It means that the reaction is polymerization reaction. So let us move. A has same type of reactants and one product, which means that there is a chemical combination of one unit repeating. Here is where we have what? We have similar monomers. I think remember that those polymers are called homopolymers. Means that we have this identical monomers. Also B has, this should also be observed. B has two different reactants and two chemical products, which means that if two substances are joined together, there is a product formed and water is released. You have seen that in the first product we have one product which also similar to the, which is a repeating pattern, of what, of the reactor. But now we have what? We have a product that is formed, and also we have something also added or released, which is water. This is the general observation that is going to help us analyzing the types of polymerization. All of them are polymerization reaction, but they are quite different. So let us enter in deep. So you will see that A is addition polymerization, whereas B is the condensation polymerization. Those are types of what? Those are types of polymerization. There are two types of polymerization reaction that we are going to discuss here. There are addition polymerization, and you have also condensation polymerization. Condensation polymerization and addition polymerization, as you have seen, are the previous one. This is the last observation on the activity that we have done above. So A is addition polymerization, whereas B is condensation polymerization. I think now you start to think about addition polymerization, how it's done, and condensation polymerization, how it's done, focusing on the activity that we have done. So let us explore those two types of polymerization. I'm going to explore them. I will show you animated video in order to see how reaction happen. It will be very interesting for you, I hope, and I think so. Let's start with the point one, addition polymerization. In addition polymerization, how this reaction happen and what examples of materials we find in our daily life, that we use in our daily life, that are made from addition polymerization. You will see the polymers that are product of addition polymerization, they are called the addition polymers, means polymers from addition reaction. So let us move. Addition polymerization is a process whereby monomers are linked together to form a polymer without the loss of atoms from the molecule. You have seen this point in the activity above. There is no loss of other atom. There is no loss of anything. All of monomers, atoms are conserved in the formation of a chain of polymers. So here there are some examples of addition polymers. Addition polymers, I'm going to be very fast. If you are watching the video, you can stop and see clearly what is the definition and write it down somewhere. Now I'm going to be hurry so that the video will take a few minutes. So here I have prepared some examples of addition polymers. Means polymers come from addition polymerization reaction. So those are polyethylene. You have seen in the previous lesson how polyethylene is formed, but now we will take a look a little bit. We'll take some example and we'll see how this double bond also is broken down, and then we form polyethylene. So there is what we call propylene, polypropylene. Polypropylene, you see plop means the three is propylene. So there is also polystyrene, polystyrene, and there is polyvinyl acetate. Those are examples of polymers formed from addition polymerization. So polyvinyl chloride, which is PVC, PVC pipe, we will explore it a little bit here. And there is rubber. And there is also polytetrafluoroethylene. This is a wrong term. Polytetrafluoroethylene. Teflon. Remember it. You use it when you are in plumbing. When you are connecting different water tubes. You remember how we use a kevlar. This is polytetrafluoroethylene. So here is we are going to explore some important examples. See reactions, how this reaction happen. We will take some of that examples of addition polymerization, and those examples will explore it in deep so that we see how bonds are broken and how they are connected. So, formation of polyethylene or polyethane. I think you remember that is ethane. So polyethylene is formed by addition of monomers molecule, which is CH2CH2, which is ethane or ethylene. Those are those are two names used in polyethylene. Those two names, you may be familiar with them. They can be called ethane. They can be called ethane, and they can also be called what? They can be also called ethylene, which is very commercial name. Ethylene, commercial name of ethane, and all of them are names of ethane. So CH2 double bond is a monomer molecule linked together to form what? To form polyethylene. Can be asked, sometimes you will be asked to show the monomers in polyethylene. They are CH2. So the reaction is like this. As you can see here, CH2 there is here, let me use blue pen. Here is a CH2, which is a monomer. You know, it has a double bond. I think you remember that. There is double bond here. Those double bond is going to be broken and open on both sides as it does here. And this repeating pattern allows the covalent bond for both sides. You can add from here, or you can add them from here. As you can see, they are opened. Those double bond open on both sides, and then you continue to make a chain of polyethylene. So now let us continue with other examples. The second example is PVC, formation of PVC, polyvinyl chloride. So polyvinyl chloride also is found in plastic lab. See, all plastic lab are made of polyvinyl chloride. Simulate the leather. Leather, you know, some leathers are not pure. They are mixed with some polymers such as polyvinyl chloride. So those water pipes, many water pipes are made from this polymer, and garden hose. You see, or many materials that we use in our life, they are made of those this polymer, polyvinyl chloride, which is PVC in short. It is formed from this. I think you remember I have in last lesson I have give you the detailed form of this form of polyvinyl chloride. You remember this is the general formula for it. This is the general formula for polyvinyl this is the general form for polyvinyl chloride. This form of polyvinyl chloride is also opened. This double bond is opened on both ends, and then the repeated pattern is done in order to make a chain, a long chain of this. And this is a good polymer that we need in our everyday life. So vinyl is common name for ethylene. Also, this is a commercial name of ethylene. But you see here, we add an atom of chloride. The reason why it's called polyvinyl chloride. So let us move on the other example. But before leaving this, I cannot live without telling you that PVC is formed from the following reaction. It's done by, you see the data form is here. Vinyl chloride, you see it. You can see the vinyl chloride here, and the vinyl chloride is a simple monomer. When it is repeated in several times, it opens this chain and this double bond, and then open chain on both sides. I have told you, see here there is carbon 1, carbon 2, carbon 3, and then you get carbon 1, carbon 2, carbon 3. You see that the polyvinyl chloride is a repetition of vinyl chloride. So let us move on another example, which is the formation of lava. Lava can be natural or synthetic. I have told you they can be formed from natural plastics like that you extract from milk yesterday, or also can be come from petroleum or natural gases. Can also made plastics. I have told you there are two types of plastics. Some are natural and the others are synthetic when they come from other natural gas or petroleum. So rubber is a natural polymer of the isoplane. Isoplane is like 2-methyl. It's 2-methyl. When we add methyl from butadiene, when we add the methyl here, we get 2 on the carbon 2. In place of having hydrogen, we can have here, in place of having here hydrogen, we can have there a CH3, which is a methyl molecule. When we get methyl here, we can get what we call isoplane, which is 2-methyl-1,3-butadiene. Means it comes from butadiene. The reason why I have displayed here the formula of butadiene. So it is formed by linear 1,4 addition polymer of isoplane. So natural rubber has elastic property because it has the ability to return to its original shape after being stretched or deformed. I have told you this property yesterday in the previous lesson. Plastics have this property of returning in their original form when the applied force is removed. The reason why also this rubber has the form, you can see from the tiles. Tiles are rubber. When the tiles are heated, they can become a viscous liquid. But when the temperature is removed, high temperature is removed, they return their form of being a hard solid. So therefore, it is known as elastomer. They are known as elastomer because of this high property of being elastic. So, natural rubber is prepared from latex, which is colloidal solution of rubber in water. You see, those are that I can say. Those are information that I can give you about that. So, let us move on other type of polymerization, which is condensation polymerization. You see here for this polymer, which is addition polymerization. For addition polymerization, you have seen that there is no molecule that is left behind. We use all atoms in what? We use all atoms in the formation of polymer. All atoms from monomer are conserved in what? In the product formed, which is a polymer. So let us move here on the next one. The next one is condensation polymerization. How is it differ to that polymerization of addition polymerization? How are they different? So condensation polymerization is a process where two or more monomers combine to form a polymer with elimination of simple molecule like water, ammonia, hydrogen chloride, alcohol, or many other that you will find in the different references that you will do. So its special property is to left behind, is to release a simple molecule after getting the product. Means that some of atoms in the monomers they are no longer in the product. Means that some of them they are rejected by the product. So now I can start by telling you that this type of reaction, in this type of reaction, each monomer generally contains two functional groups for the condensation reaction to take place. Means that there must be two functional, two different, or common, maybe common also, it can happen, but there must be two functional group. I think you have done many functional group in senior 5. You have seen many functional group that we use in organic chemistry. So condensation reaction requires two functional group. So there are two main types of functional group we use here. There are polyamides, which are formed between a diol with a decarboxylic acid, and also you remember that to find the amide we use this carboxylic acid and diol in order to get amide. So also there are polyesters. Today we are going to explore polyamides. The polyesters will be in the next lesson. So today we are going to focus on polyamides, and we explore different examples of polymers formed in this reaction of forming amide bond. So let us move. Example of condensation polymers, they can be found from synthesis of nylon. Nylon is a polymer. Terrarians, kevlar polymer. Today I'm going to focus on nylons and kevlar polymer because they are we use them frequently in our daily life, nylon and kevlar, and also proteins, polymers formed from condensation, cellulose, and bakelite. You can do your self-documentation on no other that I will not discuss in this video, but today I'm going to show you more popular, the more popular, and this is on your program. This is on your program syllabus. You must learn it in this lesson. So nylon and kevlar polymer. So now also there are many examples of polymer formed from condensation, polymerization. So now I am going to start with nylon. I'm going to start with nylon. How nylon is formed, because this nylon is one of the polyamide reaction. So let's start with this formation of polyamides. This type of polymers is formed by the result of generation of amide bond in the polymerization reaction. It means that we search a way that will form an amide bond in our polymerization reaction. So how this happens? Let's start with the formation of nylon. As I have told you, the nylon will be a good example to explain this formation of amide bond. So nylon 6,6 is produced by the condensation reaction between two monomers units. There are two monomers units. As I have told you that we need two different or common, two different or identical functional group. So here we will use what we call adipic acid. Adipic acid and 1,6-hexanediamine. Means here there is hexanediamine. You will see that is a benzene-diamine. Let us see. Okay. In the process, this reaction to happen will require heat. It will require heat. Means that in order to break bond and to bind other bond to create this amide bond, we will also need what? The presence of heat. So let us move. This is formed from a 6-carbon diacid. The acid means the carboxylic acid, and a 6-carbon diamine. So this reaction, you can see it. Here we have a benzene. Here you can see we have a benzene. You see, because we get C6. We have C6 carbons here and 2 hydrogen. Means that this is a benzene form, and in this benzene form we have 2 amines. You see, you have 2 amines. Means that there are the hexanediamine. Amine 1 will be on first carbon, and then the second amine will be on 6 carbon. So adipic acid, you see, we have 2. We have here. Let me use my zoom function to show you this one. Here is a carboxylic acid, you can see, and here also is a carboxylic acid. So this carboxylic acid, as you can see, are 2 on what? On this carbon chain. The reason why we have said 6-carbon diamine and the acid. The acid means there are two function of acid here, and this reaction will happen in presence of heat, I have told you, and also form of neutron 6 is this one. You see there are benzene here and the chain of carbon that was on the adipic acid, and also the amine group are there. You will see that there is something that will be left behind. So I can show you this by demonstrating a good video that will show you how those bonds, you will see how those bonds are broken and other molecules are left behind. So let me find a video here, and you get a good understanding, a clear of this thing, how they happen. So let me show you how this happens by using a video. This video, I hope it will be a good one, good example, a good demonstration for you on how this amide is formed, on this amide bond is formed. So let's start.
In this video I take a look at the preparation of the polyamide nylon, specifically nylon 6,6. You'll see that the numbers come from the fact that it's made from 6-carbon diamine reacting with the 6-carbon dicarboxylic acid. And here's the diamine. You can see that there are 6 CH2 groups with amine groups at both ends, so it's known as 1,6 diaminohexane. And this is the other monomer. You can see that it's a 6-carbon dicarboxylic acid. It's known as hexane 1,6 dioic acid. Let's see how these molecules interact and form an amide link. The H comes off the amino group on the left there, and it comes away without its electrons, so effectively as a H+ ion. The OH comes away from the carboxyl group of the dicarboxylic acid, and it takes both electrons of that bond between the O and the C, so it comes off as an OH- ion. The H+ and the OH- combine to give a molecule of water then. Let's now see how that process, by happening over and over again with alternate diamines and dicarboxylic acid molecules, produces a long chain polyamide molecule, nylon 6,6. So at the top left and top right I've got my monomer units. So let's grow our long chain polyamide molecule by bringing these down and alternating them to create the chain. So there I brought down one of my diamine monomers. Down comes a dicarboxylic acid monomer. You see that the C double bond O has been bonded to the NH. Down comes another of the diamine monomers bonding through its NH to the C double bond O. Down comes another dicarboxylic acid, and again it bonds through its C double bond O to the NH. And that NH-C double bond O, of course, is the amide link. So we're getting lots of these amide links as the chain grows in length. Next then, let's look at the abbreviated form of this reaction. We would take N of the 1,6-diaminohexane molecules, where N's a large integer, with maybe several thousand, together with the same number of hexane 1,6-dioic acid molecules. So we combine those. Let's take a look at how we can represent the structure of the polymer nylon 66, like this. There's an analogy I like to use here. If you have 8 fence posts, the number of spaces between the posts will be 7. Now here, if you take N plus N, in other words 2N molecules, and join them together, you're going to get 2N minus 1 peptide links, and therefore 2N minus 1 water molecules. But I've written 2N here because there's another water molecule I've removed, because I've taken the H off the extreme left and the OH off the extreme right as well. So that is balanced. So you have it, the formation of nylon 66. Thanks for listening.
So, as you can see in this demonstration video, we have seen how this nylon 6 is done, and we have seen how water molecule is here. I can show you where water molecule is released. Here you have seen that the water molecule here, the water molecule come from this HO from hexane 160 oic acid, or the adipic acid, and this oxygen come from where? Come from the amide. So you see, this bond is called the amide bond, where we link two monomers, and then we left behind what? Then we left behind a molecule of water. This molecule of water, you see that is going. Those molecule of water will be released to equilibrate, to have a balanced equation. You will use form of 2N on this molecule of water. This N is the degree of polymerization. I think you have understand well by using this animated video, because what I'm talking about is going into practice by using this animated video. I hope you understand well the formation of neuron 6. I hope you understand it very well. So let us continue our course. Let us continue our course and see and continue with the other example. So, have you tried? Are you tried with those many letters of chemistry? I've seen there are many letters that are and bonds and what. You need to have a rest. So let me give you a rest of a break of 3 minutes only, and I will turn back so that you understand. So let me left you with this simple music of the band, and you will relax, I think, through this little zouk. I think many of you like zouk. The reason why I have chosen to present this zouk as a form of relaxing. So have your break. I will return back in 2 or 3 minutes. Okay?
Maybe it's just a dream. bon, j'adore. Je peux pas vivre sans toi. Je suis perdu sans toi, baby. Oh, vas-y, vas-y, comme ça, c'est bon, j'adore. Manana, no tare. Baby, baby, you're so fine. Would you be my love forever? With you, I'm complete. Baby, oh, keep your hands on me, baby. Oh, baby, oh, baby. Oh, vas-y, vas-y, comme ça, c'est bon, baby. J'adore, je peux pas vivre sans toi. Je suis perdu sans toi, baby. Oh, vas-y, vas-y, comme ça, c'est bon, baby. J'adore, baby. Baby, and I promise to never break your heart. No more drama, no more trouble. I'll be better, yeah. So baby, do me that, do me that, baby. We no go home apart, yeah. No tired, baby. Oh, vas-y, comme ça, c'est bon, j'adore. Je peux pas vivre sans toi. Je suis perdu sans toi, baby. Oh, vas-y, vas-y, comme ça, c'est bon, j'adore, baby. Manana, no tare. Baby, baby, you're so fine, would you be my love forever? With you, I'm complete. Baby, oh, keep your hands on me, baby. Oh, baby, oh, baby. Oh, vas-y, vas-y, comme ça.
Okay, maybe you have enjoyed your break. Let us continue with our lesson. So, I would like to make you relax. I have seen that the letters of chemicals and the atoms have been a lot. So now we are going to start with the second form, the formation of kevlar. Kevlar, we see, it has a great importance in our real life. Kevlar, read kevlar. Kevlar is formed from the polymerization of benzene 1,4-diamine and benzene 1,4-dioic acid. Means that also there is two acids and two amine group. You see, there is the amine here. You can see here it is the amine. There is the amine here. Here there is the amine. And also there is also the oic acid. Means that there is the acid and the amine. Those are going to make bonds so that there is a formation of amine bond, and then we get a multiple units of this. I will show you this also in a good animated video so that you will be familiar with these reactions. So from the formulas you can see here there is a structure of benzene here, and also there is two acids, the carboxylic acids, and here there is the amine, there is a benzene structure, and here there is also the amines. So these amines will break, and then there is some of molecules of water that will be released. So let us move. Then this also will give us a product of kevlar. This is a structure of kevlar. When times you forget it, I have seen in different tests that I have given in last year students, they fail to memorize it, but it is very easy when you see the you see the monomers is benzene. You know the structure of benzene. There is 2 benzene and 2 amine and 2 carboxyl, and then but after the formation of the amine bond, which is here, amine bond, there is a formation of kevlar and the release of water. So you will see how this water is released in the animated video that I'm going to show you next slides, I think. So in that polymerization, what happened in order to form a molecule of water? So this amine group of hexamethyl hexamethyldiamine react with carboxylic group of adipic acid to form what? To form NHCO amide linkage. This will eliminate the molecules of water. You see, the reaction happened between carboxylic acid and what? And the amine group. As you can see here in this animated video, you will be familiar, very familiar with this through this animated video of kevlar. Kevlar is a very important, you will see in the next slide. But let's explore this video. In this video, there is a good demonstration. There is a good demonstration of what?
The chemistry of kevlar.
There's a good demonstration of
Kevlar is a strong, lightweight polymer made of many amide groups put together to polyamide. It can be used in car tires, brakes, and the bodies of vehicles, but perhaps its most well-known usage is a stab-proof or indeed bulletproof armor, much like Dr. Atkinson is wearing here. So how does it get these properties and what's its chemistry? Well, these are the 2 molecules that react together to make Kevlar. 1,4-diaminobenzene. On the 1st and the 4th carbon, there is an NH2 group, which gives you the diamino. And if you don't know that benzene is 6 carbons in a hexagon with single and double bonds, you're in the wrong place. The second reactant is benzene 1,4-dicarbon.
Remember, this is another form of expressing the structure of benzene. Remember, this is a formula of benzene. We can represent by showing the double bonds, 2 double bonds, but also we can also represent it in this way. So this is another way of presenting benzene. So let us continue our video.
Chloride. Carbonyl, well, that's a carbon double bonded to an oxygen, and it seems reasonable that if you stick a chlorine onto that carbon, it would be carbonyl chloride. So when you put these reactants together, the hydrogen and the chlorine there becomes hydrogen chloride, and a covalent bond is formed. Now this happens many times in an enormous chain. The square brackets show the repeating unit. Don't forget to have the bonds stretching outside of those brackets of n repeating units. And again, this is indeed Kevlar.
So you see the kevlar release the molecule of H chloride. It's not water as I have told you, it's H chloride.
It might help you also to know that the H and the Cl will fit on the outside of that repeating unit. So here's the equation written out in full. It's 2n minus 1.
In order to balance this question, you will follow this formula. Because n here, it will be 2n. That n we use here is n for the degree of polymerization. So n here, 2n negative 1 will balance this equation about the acid that will be released.
Those tiny little molecules of HCl that are produced from N on each reactant. Again, there's the chlorine and one of those hydrogens that come off. And I'm going to highlight the amide group here. Now there are many, many, many of these repeating units, n of them. So this is a polyamide. Poly means many. So it's a condensation polymer, which means a small molecule is also produced. Water, hydrogen chloride, methanol, or even ammonia. So then, it's not going to be 100% atom economy, is it? I'm making some waste. When the molecules of Kevlar are weaved together, they end up in parallel.
Now, you will see how Kevlar become a very strong substance. Kevlar. It becomes strong substance, as you will see in their use. In our daily life, they are used as a bulletproof for policemen, for other military uses, other military agents. But for bulletproof, even a bullet cannot break this Kevlar substance. It means that they have a higher resistance. They are very tight, so that nothing can break it. You will see now. Up to this step of this video, you are going to see where this strength comes from. It comes from the hydrogen bond that is going to be formed, because when they are condensed, they are near each other. I am going to let you see this very clear in this video.
Like these three chains here. Now, if you see the oxygen atom on the top molecule, that's a little negative compared to the carbon atom it's attached to. And oxygen is more electronegative than carbon. And directly below it, there's another polar bond. So now I have the negative and the positive of those two separate chains. A little negative, a little positive, and that's called a hydrogen bond. That's the electrostatic attraction there. Remember, when hydrogen is attached to nitrogen, oxygen, or fluorine,
you can see that there is hydrogen bond, and the hydrogen bond is a higher strong bond. It's a strong bond that's tied together many chemicals.
Has the ability to make intermolecular bonds, and these hydrogen bonds are some of the strongest intermolecular bonds. So these chains of Kevlar are now very tightly bonded together. So Kevlar has cross-linking hydrogen bonds. But if you get it close to acid, then the protons are going to be attracted to the oxygen and the nitrogens and disrupt this hydrogen bonding, thus weakening your Kevlar. And in this weakened Kevlar, the chains may pull apart, and it will be easier for a knife to enter or a bullet to enter. Now, if you have lots and lots of acid, not only is the hydrogen bonding between the chains disrupted, also the amide.
So all acid can break this, but by using bullet action of other materials, they cannot break those
bonds are now broken within the chain, and the Kevlar becomes useless. So how is it bulletproof? So the kinetic energy from the bullet hits the Kevlar, and that energy is used literally to break the bonds between the strands of Kevlar. And so instead of the energy going into you and killing you, it goes into breaking chemical bonds. You're going to get some bad bruises and probably need to change your trousers, but you'll probably live to fight another day.
So Kevlar is very strong. It's very strong, as you are going to see. As you are going to see here in our presentation on the use of those polymers in our daily life. They are very, very strong. And the use of neon 6 and Kevlar polymer. You will see that polyamides such as neon and Kevlar are widely used in clothing. Many clothes are made from those polymers. Kevlar has some remarkable properties. They have their specialty for fire resistance. They are very strong. To break its bond, it takes high energy to break their bond, because they are very strong. Higher strength than steel. They are hard, very hard. They are harder than steel. They are very hard compared to the steel. So it is used to make what we call protective clothing. Protective clothing, for example, for fighters. bulletproof vest. You see, the bulletproof vest for policemen, they cannot be broken by even the bullet from the gun. So you see, it's very strong because of that hydrogen bond, which is very strong. It is an intermolecular bond, you remember, which is very strong. They tie together molecules so that they cannot be broken, despite of the action of strong acids. So now I can stop here. The next part of this lesson will be here soon on the formation of polyesters. We have seen that this polymerization, this condensation take place in two ways: polyamides or polyester. The next lesson will be on the formation of polyesters. So today we are going to finish here. See you in the next lesson. I have shown you my contact. I think you will contact me for support, for addition. You know that when teacher is teaching, also he is studying. You can also give me an advice. You can give me a support. You can give me anything. I'm welcome. And don't forget to subscribe on this YouTube channel so that you get updated lessons. We will have many lessons. Now I'm with other teachers you have seen. I've got a good team of teachers. We prepare different subjects. I'm preparing science, but I have other tutors that will help me to prepare other subjects such as history, geography, mathematics. Now I'm going to post another of inclusive education. Others are preparing for, and now you will see that you will find resources that will help you to learn in this period of pandemic 19. Don't forget to subscribe. When you subscribe, you get update video after we publish it, immediately after we publish it. So thank you. I will be back. I'll be back soon in the second part of this lesson about what about polyesters. So thank you for your attention. Hope you enjoy our lessons. Thank you so much.